This video is about converting from one unit to another. In general, metric units, but not necessarily. I know you probably have other ways in which you do this, but I'm going to teach you a technique here called dimensional analysis. And the reason I'm going to teach you this technique is because I think it is extremely useful. For right now, the math is sort of easy, but we're going to get harder and we're going to get more complicated problems. And for those things, dimensional analysis is the way to go. So I'm going to ask you to use this technique to do your math when possible, okay? Now, when I was a child in chemistry class, just like you, we did this same method. My teacher called it the straight line method, because that's what it is. It's working on this thing called the straight line. Really, it's a variation on multiplying fractions. If you're in math class and you had two fractions you want to multiply, let's say 1/2 times 2/3, you would do something like that. Then you would cancel out these 2's and you would say, oh yes, this is equal to 1/3. Well, we're going to do something very similar to that, except instead of parentheses, we're going to use a straight vertical line. But it means the same thing the parentheses mean. It means multiplication. Okay, so anytime you see a straight vertical line, that means multiplication. And just like you have this line in a fraction, this is what I mean by on the straight line. There's my straight line. Just like it means in the fraction, this means division. All right, so if I did this, this equals the same thing as this. They are the same thing. It's just a slightly different notation. Now, the reason we do this is because unlike math class, here in science, every number you write has a unit. So when you're multiplying and dividing these numbers, you have to keep the units straight. And on the straight line, this dimensional analysis is the way I think it's easiest to keep these numbers straight. Okay? Let's start with a very simple problem. How many seconds are in 3.00 minutes? Okay. So 3.00 minutes. There's my dimensional analysis. The thing that is given to you in the problem always goes here in this first square in dimensional analysis. Then the unit that is of the given goes right down here, so it can cancel. You'll notice I'm not canceling the number, I'm canceling the unit. There's a difference. So that's one secret to dimensional analysis. Whatever unit's up here has to go down there so it can cancel. Then the other secret to dimensional analysis is the top and the bottom have to be equal. Because really all we're doing here is changing units. We're not changing, in some sense, the value of the number. It's not getting bigger or smaller. It's simply changing unit. So if the top and the bottom are the same, it means we're multiplying by 1 every time. So that's not changing the value of the number. It's merely changing its unit. Okay, so what we need here, if I say 1 minute here, what we need up here is something equivalent to 1 minute, because the top and the bottom have to be equal. Well, I know that there are 60 seconds in a minute. Okay? Minutes have canceled. I'm left with seconds, which is exactly what I want the unit to be in. Good. I'm doing this right. So now I say 3 times 60, because vertical line, that's a multiplication, 3 times 60, divided by 1, though of course that doesn't change anything mathematically, but this line means division. So 3 times 60 is 180 seconds. Okay? That's how dimensional analysis works. Okay? Okay, now let's try this on metric. I have, let's say, 3.69 millimeters. How many meters is that? Okay, so again, 3.69 millimeters. There's my given, so it goes in that first thing right there. Millimeters is here, so I'm going to put millimeters down there so I can cancel it. I'm heading to meters, so I'm going to put meters up here. Now I need the top and the bottom to be equal. So I think to myself, milli. Milli means 1,000, 10 to the third. Now, is it that there are 10 to the third meters in a millimeter, or is it that there's 10 to the third millimeters in a meter? Okay, a milli is a teeny tiny thing. So I must need a lot of them to get up to 1 meter. So it's 10 to the third millimeters in 1 meter. The 10 to the third is on the bottom. Now, don't take that to mean the 10 to the third is always going to be on the bottom. That's not true. It is true that 10 to the third will always be next to millimeter, and millimeter is on the bottom because millimeter has to cancel with millimeter. See, this is why I do dimensional analysis. It keeps it straight. You know, in this case, you have to divide by 1,000 instead of multiply by 1,000. So now I just do 3.69 divided by 1,000, which is 3.69 times 10 to the negative third meters, or, if you prefer, 0.00369 meters. Okay? Now, these lovely dimensional analysis things do not have to be one step. It could be more than one step. For example, what if I have, 8.11 microseconds, just so that I don't do meters again, and I want to know how many centiseconds that is. Okay, now, there's a prefix in front of this base unit, and there's a prefix in front of this base unit. That's going to be a two-step dimensional analysis. Okay? Because off the top of my head, I don't know how many microseconds are in a centisecond. And you know what? I don't care either. I cannot memorize every conceivable connection between every conceivable prefix. I'm just going to go with what I have memorized. I know that for every 10 to the 6th microseconds, there's a second. I know that because micro is a teeny tiny little thing, so the big number has to go next to the small unit. So there's 10 to the 6th microseconds in a second. And then I can also say that for every 1 second, there's 100 centiseconds. Okay, so I've made this a two-step problem. The whole point of dimensional analysis is not to have to go off to the side and do math on the off of it. You just make it a two-step problem. You know there's 10 to the 6 microseconds in a second. You know there's 100 centiseconds in a second. Just put those down. Once again, you'll notice the units cancel. And I'm left with the unit I want. So I know I did it right. And, in fact, the unit I want is on the top. So that's a good thing. So now, again, I do math. 8.11 divided by 10 to the 6th times 100. That's actually going to give me 8.11 times 10 to the negative 4th centiseconds, which makes sense as an answer because a centisecond is a bigger thing than a microsecond. You know, it's worth it, by the way, when you do math, to stop and figure out if the answer makes some kind of sense. These can actually get harder, but I'm going to save that for another video. Let's get used to this technique first. Okay? We'll stop it there.